Hello guys, let me welcome you again to our second, test lesson in physics on the topic of friction test. So guys, be attentive because this is one of the simplest topics in Form 4. So be attentive. Friction force. What do you think is it? Because it's time to train your brain. What do you think friction force is? 5 seconds. So friction force, this is a force which is between the two surfaces which are in contact and in opposite direction, or they do oppose the motion. The force which are found between the two surfaces which are in contact and opposes what? Motion. This is what we call friction force. So these forces have its causes. They have causes which causes friction force. They have the causes which make these things to oppose the motion. So one of the causes of friction force is the surface itself. It has the rough projections. It has the projections which interlocks, hence opposing the what? The motion. And the second one is the adhesion and electrical properties. There is the force of adhesion, the force of clinging to the surfaces itself, hence opposing the what? The motion. So these forces are present there. They are there even if there is no motion. Even if the bodies are stationary, but the forces are still there. So if you see there, it is at the foot there, you see the shoe is in contact with the surface of the earth, and there is some projections, as you can see on the simple diagram there, some projections which are interlocking. Those projections are there. So for you to start walking, for you to start moving, first you have to get lead of the what? Of the projections which have been interlocking. You have to apply force, and the force have to get lead to those projections. Then the moving will be there, unless no any motion. So types of friction. We have two types of friction. One is static friction, and the second one is kinetic friction or dynamic friction. Guys, when we're talking about friction, I'm saying that this is the simplest topic. Why? Because when we are talking about friction, this is just a topic which we experience each and every day in our livelihood. Almost each and every machine we are using, it does experience the what? The friction force. Let's look about the knife. Let's look at the knife. You are using a knife to cut your objects, to cut meat. As you are cutting, you are experiencing friction force. As you are walking yourself, you are experiencing friction force. As you are driving a bicycle, you are experiencing a friction force. In whatever you do, which force is there? There is a friction force. So, what is static friction? So, static friction, this is just the force that is applied to an object, and it does not cause the object to move. You apply a certain force, but the object does not move. Maybe the force you applied is low, is not enough to to remove the friction force under it, to adhere the friction force under it. So that's what we call static friction. As you can see there, a person is pushing an object, and that object is not moving. This is where we say where is the velocity is equal to 0. It's not object. It's not moving. The object is at rest. If you see at the free diagram here, where we have a block on the table, you see that the force has been applied to the right, and the block itself, it is applying another force which we call it normal force. It is applying to the table, and again due to the principle of third law of uh, Newton's law, third Newton's law of motion, where we say that whenever an object is applying force, there is the object itself, it also applies an opposite what? Force to the object. Whenever there is action force, there is reaction force. So a block there is applying a force, a certain force to the table, and a table returns the same force to the block. That's what we call weight and the normal force. So for you to find the static friction, we will use a formula where we say the static friction is equal to the coefficient of static friction multiplied by the weight, or the normal force, since it is just the same. So let's look what are some of the examples under the static friction. There's a problem here where we say a wooden block weighs 100 Newton and is sitting stationary on a smooth horizontal concrete surface. The coefficient of static friction between wood and concrete is 0.2. A 5 Newton horizontal force is applied to the block, pushing toward the right. But the block does not move. What is the force of static friction of the concrete on the block? That's the first question. And the second one, what is the maximum pushing force you can apply and how the block will remain stationary in problem 1? So let's look how we can do it, that problem. Okay, we're saying that first of all, let's start with the first question, and when we are solving a problem, we have to determine what we have given. So first of all, we have given the applied force. That's the applied force. Yeah, applied force. That's AP. So we have given AP, where the that applied force is what? Is 5 Newton. That's the applied force we have given. And also we have to determine if it is in stationary or it is it moving. So the body is not what? Is not moving. It is in stationary. And so as I already said, using the third law, Newton's law of motion, the third principle, which says whenever there is an action force, there is the reaction force. The amount of the force is the same, but in opposite what? In opposite motion. So the force applied here is 5 Newton, and this force is not able to cause the object to move. It is stationary. So if the object is in stationary, that means we also said to in the second principle of Newton's law, wherever we say that the net force when an object is stationary, it is equal to 0. It must be equal to 0. It must be cancelled to 0. That means for 5 Newton to cancel it to 0, there's also again a force which is acting on that. That is on what? The friction force of again 5 Newton. So here the static friction which we have asked to find, that the static friction is also equal to what? 5 Newton. Well, that means we have dealt with this question. So let's look about the second question, which says what is the maximum pushing force you can apply and how the block remains stationary in the problem. Okay, let's look to that question. So first of all, let's determine that we have given, and also what which will be needed to use to solve that question. So first of all, we have the static friction. I mean the coefficient of friction. We have given the coefficient of what? Of friction, of static friction, which we have taught that it is 0. What? 0.2. And also we have given the weight of what? Weight of the object, which have been taught it is 100 Newton. Also we have also given what is called the applied force, but here the applied force, I think it wouldn't be used, so it is not necessary. So our formula for finding static friction: the maximum pushing force, the maximum force, that means the static friction, which are in between the object, the maximum. That means kuri muntu chintu chechiyende yofunika ipatsidwe force yodutsira pa force imene ilipo kale. So there you will say F S, that's the force of static friction, is equal to the coefficient of static friction multiplied by mg. So here the static friction force we have given it is 0.2. You multiply by the weight, which is mg. The weight we have told that it is 100 Newton, something like that. It is 100 Newton. So if you multiply 0.2 multiplied by 100, you will find that the answer is 20. So the force which is the maximum to hold the surfaces not to move is 20 Newton. The maximum force which can be applied on the object and the object is still not moving is 20 Newton. Okay, that means kungamba kuika 1 here, if it will be 21 Newton ubino chintu chiyamba kurani chiyamba kusunta. So that's it. That's how we do with these questions. Let's continue our work. On the same types of friction force, I was already said that we have two types of friction force. This one we have talked about the static friction, and now let's go talk about the kinetic friction, also called the dynamic friction. So kinetic friction occurs when force is applied to an object and the object moves. The force now it has been applied and it has caused the object to move. Okay, and that's what we call the kinetic friction. It also called the dynamic friction. So, example, sliding friction. You are pushing an object across a surface, the other on the other way and the other coming on the other side. And again, friction wheels. The wheels and the surface, the wheels are able to move on the surface. When the certain force has been applied and the force that has been applied, it is able to go above or to bypass or to push away the friction. I mean the friction force. Then there's fluid friction, which opposes the motion of objects traveling through a fluid. A good example is when a person is swimming. The fluid, that's the water, tries to push him or her back. So for him to continue moving with the fluid, have to exert a force which will bypass the friction force in the fluid. The same again here, you see the person now has exerted a certain amount of force, and the force he exerted has caused the object to move. So on a free diagram here, you will see that the force has been applied and the object has been moved to the direction where the force is being applied. Okay, could you saying the force applied to the right, that means the object has to move to the right, not the force applied to the left, to the right, and the object is moving to the left. No, something's wrong. So for the formula of finding kinetic friction force is just Fk, which is kinetic friction of kinetic, equal to coefficient of kinetic multiplied by the weight or the norm force. So there's also a problem here, which will say a wooden block weighs 100 Newton and is sliding to the right on a smooth horizontal concrete surface at a speed of 5 meters per second. The coefficient of kinetic friction between wood and concrete is 0.1. Then a 5 Newton horizontal force is applied to the block, pushing toward the right. What is the force of kinetic friction of the concrete on the block? What do you think? How should we study? 10 seconds, because it's time to train your brain. Okay, let's do it together now. I think you know most of Vagale. Mwabiza sugale mansa like you know in the mayaza, you know. You know in the mayaza, my guy. So what we're talking here, first of all, the first thing you have to be to determine what we have been given. First, we have been given weight. That's W, which we call it weight, which is equal to we have been given weight, which it is equal to 100 what Newton. The weight is equal to 100 Newton, and we have also given coefficient of friction, coefficient of kinetic friction, coefficient of kinetic friction. The coefficient of kinetic friction, which we are saying that is equal to 0.1. Okay, so now you made about on that. We have said we have given the velocity, and the velocity v is equal to 5 meters per second. This just shows us that the object is what is moving, and so we say we have to find the normal force. So we have already said that the normal force is equal to just the weight. Therefore, the normal force here, it will be equal to what? It will be equal to 100 Newton. So no need to bother ourselves there. Then we have to calculate the kinetic friction. So the formula we have already given, where we say the kinetic friction here is just equal to the coefficient of kinetic friction multiplied by the mg, that's the weight. Yeah, so the coefficient there, we have already given the coefficient of friction as 0.1, and we have been given the mg, which is the weight, as 100 Newton. 100 Newton. If you do your calculations there on the scientific, it will give you 10 what? Just have to be 10 Newton. It will give you 10 Newton. So in this form, maybe mudaba wuda tinalindi velocity, you know, that the velocity is just showing you that the object is moving, but here you can't use it in any way. And also what about the on the question, and also there is a 5 Newton force which is applied in the other way, in the left, on the left, while the object is going to the right. I mean, you just leave it. Since when we're talking about kinetic friction, it means that the force which has been added there, it has to be greater than the applied force. That's what we have found that in there. It is greater than the applied force. Friction greater than the applied force. So let's call it a day and have a nice night, or say a good night, because this lesson is they'll see good. Yeah, Kalena, you still have some things to do. So let's meet again on Monday. Oh no, not Monday. Tomorrow, which is Saturday, we will have a test which will comprise biology, physics, and agriculture on the same, adding up to 100 marks. It will be just in individuals. It will be maybe tomorrow or Sunday. Thank you guys. Have a nice holiday, a nice weekend.